Dear students, in the previous class we discussed about the how to prepare the ethers by using the Williamson's ether synthesis and by dehydration of alcohols. In this class, another method of preparation of the method of preparation of phenolic ethers means the phenolic ethers, how we are going to be prepared, we are going to be discussing in this class. That is the preparation of phenolic ethers. Preparation of phenolic ethers. When it comes to the preparation of phenolic ethers, in this alkyl halide is going to be treated with the sodium phenoxide. Alkyl halide is going to be treated with the sodium phenoxide. At that time, it is going to be formed that phenolic ether. Suppose it is going to be taken that alkyl halide, that is RX, is going to be treated with the sodium phenoxide C6H5. This we call as a sodium phenoxide. The name of this compound is sodium phenoxide. That is alkyl halide is going to be treated with the sodium phenoxide. We are going to be get that phenolic ether. Then NaX. That is Na sodium halide. Then if you are going to be taken the example for this, that is ethyl bromide. Is going to be treated with the sodium phenoxide NaOC6H5, sodium phenoxide. Then it's going to be formed that ethoxybenzene. That is ethoxybenzene C2H5O, then C6H5. The name of this compound we called as a ethoxybenzene plus NaBr, sodium bromide. This about the method of preparation of, that is a preparation of phenolic ethers. Generally we are going to be represent in this above equation the general representation of the preparation of phenol ethers. We are going to be written like this, but in particularly we come to that is ethyl bromide is going to be particular example. Ethyl bromide is going to be treated with the sodium phenoxide. We are going to be get that ethoxybenzene. Instead of ethyl bromide, we are going to take the methyl bromide, and that methoxybenzene we are going to be get. This is the method of preparation of phenolic ethers. The next, up to now we are discussed about the preparation of ethers, means by dehydration of the alcohols, and another method is Williamson's ether synthesis, and this preparation of phenolic ethers we are discussed until now. Now we are going to be discussing about the properties of ethers. When it comes to the properties of ethers, we are going to be discussing as physical properties first, then we are going to for the chemical properties. First we are going to be discussing about the physical properties of ethers. When it comes to the physical properties, we know that already. Physical properties means we are going to be discussing the state, color, like this we are going to be discussing boiling point. These and all we called as a physical point, that is physical properties. The first we are going to be discussing with that is state of the ethers. Means these exist ethers, that is dimethyl ether, then diethyl ether, ethyl methyl ether. These are gases at the room temperature. Other lower members, we are going to take another lower members are colorless liquids. Means here we came to know that it is a colorless liquids. Means color and the state we came to know that is some members are gases at the room temperature and other lower members of ethers are the that is going to be colorless liquids and highly volatile. The ethers are highly volatile. Means lower members are of ethers are colorless liquids. Then highly volatile. Then it's highly, that is lower members are colorless liquids, highly volatile. Then volatile means evaporating. It's not be present in the liquid state, it's going to be evaporated to the gaseous state. Then it is sparingly soluble in water. Then it's having the low boiling point compared to the isomeric alcohols. This is about the some physical properties of ethers. Physical properties of ethers we are going to be discussing. That is, these some lower members are gaseous state and some other lower members of ethers are the colorless liquids. Then these ethers are highly volatile and it's having the low boiling point and it is sparingly soluble in the water. This is about the physical properties of ethers. The next we are going to be discussing about the chemical properties of ethers. When it comes to the chemical properties of ether, that is the first we are going to be discussing with the cleavage of the CO bond. That is the cleavage of the CO bond. When it comes to that cleavage of the CO bond, that is before going to this cleavage of CO bond, these ethers are inert in nature. That means inert in nature means easily not be reacted with the other compounds or other elements. Means it needs some special, that is reagents to react with the ethers. Means here some reagents which is used are, that is halogen acids and sulfuric acid, phosphorus pentahalate. These are all the reagents we are going to be used in the chemical reactions of the ethers. The first we are going to be discussing about the cleavage of the CO bond. Cleavage of the CO bond. When it comes to that, first the cleavage of CO bond, reaction with the chemical properties. In the chemical properties, the first we are going to be discussing with the reaction with hydrogen halide. There is a hydrogen halo acid or hydrogen halide. Then these, suppose ethers reacts with the excess of, that is the excess of halo acids, means that there is a hydrogen halide. At that time we are going to be get that alkyl halide. The first, if we suppose it reacts with the less amount of hydrogen halide, suppose the ether R is going to be this ether, the general representation of the ether. Ether is going to be treated with the hydrogen halide, less amount of hydrogen halide. At that time we are going to be get that alkyl halide and the alcohol. That is alkyl halide and alcohol. We are going to be get that alcohol, means less amount of hydrogen halide. If suppose again it reacts with the excess amount, at that time the alcohol form is going to be again reacts with the excess amount of the hydrogen halide, we are going to be get that alkyl halide plus H2O plus H2O. This about the, that is the reaction with the hydrogen halide. Means this we can be written in the one equation, that is going to be RORL is going to be treated with the two molecules of hydrogen halide. At that time we are going to be get that 2RX. It is 2RX plus H2. This is about the overall reaction. Instead of writing these two above two equation, we can be written this when the ethosis reacts with the excess amount of, that is hydrogen halide. This we are going to be discussing by taking some examples. Some examples we are going to be taken instead of, that is the general form. We will take the example for this reaction. Means that is a reaction with the diethyl. Example for that reaction. Instead of ether, we are going to be taken diethyl ether. The diethyl ether we can write as C2H5O C2H5. This we call as the diethyl ether. Diethyl ether. This diethyl ether is going to be heated with the less amount of concentrated, that is the concentrated hydrogen iodide. The concentrated hydrogen iodide. When that is a diethyl ether is going to be heated with the less amount, that is going to be in bracket, if you want you can write less amount of concentrated that is hydrogen iodide. At that time we are going to be get that the products, that is the C2H5OH plus C2H5I, means that is the ethyl alcohol plus ethyl iodide. We are going to be get. If suppose that is a diethyl ether is going to be treated with the diethyl ether is going to be treated with the more amount of that is a excess of hydrogen iodide, means the excess of hydrogen iodide. At that time we are going to be get that is two molecules of, that is ethyl and C2H5I, means ethyl iodide plus H2. This about with the excess, this about the with the less amount of concentrated hydrogen iodide. In this you can in the examination they are going to be asked with, if it is ethyl, that is diethyl ether react with the less amount, we are going to get the two products. Which one? That is, one is alcohol, another one is alkyl halide. If it is reacts with the excess, at that time we are going to be get that the alkyl iodide, alkyl halide we are going to be get. That you should be remember. Means how it's going to be react with the less amount of hydrogen halide, how it's going to be react with the excess of hydrogen, that is a hydrogen halide. You should be remember. Then next we are going to be discussing about the how it's going to be, that is a hydrogen halide, how it is going to react with the alkyl halide ethers. That is a reaction. That is the next one. A reaction of alkyl halide ethers with hydrogen halide. You should be remember that. That is alkyl aryl group both should be there. That we call as the alkyl aryl ether. Then generally we can be represent alkyl aryl ether is going to be represent like this. This alkyl group, this aryl group, this together we call as that is alkyl aryl ether. This together we call as alkyl aryl ether. This is going to be treated with the hydrogen halide. Here, instead of breaking this, that is aryl oxygen bond, it's going to be breaks the alkyl oxygen bond. This bond is going to be break. This bond is not be broken because of this is more stable. That is aryl and oxygen bond is more stable than the alkyl oxygen bond. Due to this, the alkyl oxygen bond is going to be broken. Then we are going to be get that is the phenol and plus alkyl halide. Alkyl halide we are going to be get. If you need, you can take some example. Ethyl benzene. If you are going to be taken that ethyl benzene, the ethyl benzene means OC2H5. This we call as ethyl benzene. Is going to be treated with the hydrogen iodide. At that time, we are going to be get that the phenol plus C2H5I means ethyl iodide. Phenol and ethyl iodide we are going to be get. Means this about the cleavage of the CO bond. Means cleavage how it's going to be the bond between the carbon and the oxygen is going to be break. Then the reaction with the alkyl aryl ethers with the hydrogen halide is going to be breaks the bond between the alkyl and the oxygen group. It doesn't break the bond between the aryl and the oxygen. This about the methods reaction with the alkyl aryl ethers with the hydrogen halide.